Okay, so in terms of the exam is scheduled for Wednesday, December 3rd. That is this Wednesday. And what you should expect in the exam is the same format that you have seen for the first two. You're gonna have section one, which is multiple choice, 10 questions, multiple choice, or true or false questions. And then section two is 2 to 3 problems, which can be short answer, explanation, description, or mathematical. So one more time, my suggestion for you is to go over the slides, read through them, make sure that you understand the concept. Not only what is written in these slides, but also if we are applying an algorithm for a certain type of problem, why are we applying the algorithm for that problem? Uh, Other type of questions could be what type of systems, for example, when we are analyzing conveyors, we are looking at specific systems, like the ones that were the cars with certain capacity, and we were trying to plan for those. There were certain things that we needed to consider in order to plan for those type of systems. Okay, so make sure that you read through and understand the purpose of the algorithm, what type of system we were trying to model, why are we planning for those systems, and so on. So in terms of the material, um, the first lecture was lecture 10, which was conveyor models, and we talk about trolley and similar conveyors with discrete carriers. These are conveyors with loops, with deterministic loading and unloading sequences. So we have a specific type of model for those conveyors. And then we consider another type of system where we had pause on arrival. And we had different type of methodology to solve for those problems. Then we transitioned to lecture 11, which was warehouse operations. And in this lecture, we cover the missions of a warehouse, the functions in the warehouse, the receiving and shipping operations, and the storage operations. So we discussed the important things about managing a warehouse and all the things that involve when you're trying to operate this type of facility. Any questions? Then we have lecture 11, part 2, which was warehouse operations. So in this one in particular, we described the warehouse layout model, which was a linear programming model. And essentially what we're trying to do is to find the optimal allocation of the items in a warehouse. And we discussed why it's difficult to solve such type of problem. Sometimes when the model gets too big, it will take you a lot of time or computer time to solve such type of problem. So that's why we came up with algorithms to solve the problem. So you need to make sure that you're familiar with the algorithm that we discussed in class for solving that problem. And finally, we discuss storage systems. We describe some of the most important systems that apply to warehouse operations and so on. And our last lecture was a single facility location model. In this one, we were, instead of looking within the facility or the design of the space inside the facility, we were trying to allocate a facility in a location, let's say a map location. So you have certain facilities, you have 5, 7, any number of facilities, but those could be your customers, and you're trying to allocate or place this new facility in the best location so you can serve your customers. So that was the last thing we did in class, and that's the last topic that is going to be included in the exam, which is on Wednesday. Any questions? Okay, so in terms of preparation, go over the lecture slides, make sure that you understand the concepts, why are we using these algorithms, and so on. Bring your calculator to the exam, and labs are important, homeworks are important, so you make sure that you understand the problems that we solve in class and in the homework. The exam is closed book and notes, and the only other item you will be allowed to have in your desk is your calculator. And always remember to show your work. The more you write in your paper, the best chances you have to get a partial credit. Now, in terms of your grade distribution, as I mentioned at the beginning of the semester, you have two options. The first option, and I have them here, the first option is that you take the final and you decrease the percentage or the weight for some of the exams, for all the exams that you took during the semester. So the final will give you a boost if you do well to improve your grade. In terms of homework, quizzes, and labs, I always delete or eliminate the score that affects you the most. So I will drop one of the scores from your homework or quizzes. Homework or lab, we didn't have any quizzes, but this is the first option. And the way this works is I'm going to grade your exam. I'm going to let you know what's your grade based on this. So your grade based on not taking the final, and then you're going to make a decision whether you want to take the final or not. If you have questions about how much you need to make in order to go to the next grade in the class, I can answer that question by email. Okay? But you should be able to compute that using these percentages. If you want to make sure that you have the right number, you can email me and I will reply with the figure. Okay? So these are your two options. If you're doing well, then you don't have to take the final. Any questions? In terms of the final format, I haven't designed the exam yet, but I can give you the details on Wednesday once I go over the design of the exam. But it might be more, I will give more weight to concepts. You will not see a lot of problems. It will be more understanding the concept for the class. So you should expect more questions or draw polls or more multiple choice type of questions. Okay? And the last thing, I need to the last thing we're going to do today is to discuss the homework. So I'll give you the opportunity to ask questions. This is very simple. Again, what we are trying to do with this type of problem is to find the optimal location of your new facility. So this is the information from, it didn't put the data. So let me find the yes, the only one that is not there is the one that I'm going to discuss now. Okay, so this is the problem. We have information about 6 different centers with their location in the regions that they are located. So we have the X coordinate and the Y coordinate for each one of these 6 facilities. And we have the weight in terms of the number of trips that you have to make to that facility or to that center from the new facility. Okay, so that's what that weight means. And we are asked to determine the optimal location for the new print shop using this information. So again, you can solve this problem by formulating the linear program and solving that using the computer, as we showed in class. But that would be possible for you to do in the exam. So what we're going to do is we're going to focus on the algorithm, and we're going to use the algorithm we discussed in class to solve this problem. So we have the first step. I'm going to solve this first for the X coordinate. So we have the following. Okay, so we have center I, we have coordinate AI, we have the trips or WI, and we have the sum of WI. So if you remember how to apply this algorithm, we're going to look at the information that we have in terms of the X coordinate and the Y coordinate. We're going to sort the information in terms of the values in non-increasing, in increasing order of AI, which are the coordinates. And then based on that, we're going to look at the coordinate that provides you with the weight or the sum of weight that is greater than half of the sum of all the weights. Okay, so we start by sorting the data. So we have 5, 15, 25, 30, 35, and 50. Okay, so in increasing order, we sort the data in terms of coordinate X. And thus, that corresponds to center A, E, C, F, D, and B. And then we can look at the weights for each one of those centers. So for A, that's 200. For E, that's 400. For C, that's 500. For F, that's 600. For D, that's 300. And for B, that's 400. Okay, so once you have the information or sort the data in terms of the coordinate, then you're going to look at the center and you're going to use the values for that center. So this should correspond to the center. Now what we're going to do is we're going to sum, or we're going to look at the cumulative values for these weights in that column. So the sum of WI, this is 200, 600, 1100, 1700, 2000, and 2400. So the last step is to compute 1/2 the summation of the centers from 1 to 6 WIs. So that's 2400 divided by 2, that's 1200. So we're going to use this number to find the location in terms of X for our new facility. So we're going to compare this number against this, and 1200 is not great, is is greater than 200. So we look at the next one. 1200 is greater than 600. 1200 is greater than 1100. And 1200 is not greater than 17. So that means that our coordinate in terms of x is there. Because this is greater than 1200. Any questions? So now we have to repeat the process for y. So let's look at the data. So we do the same thing. We have center I, coordinate, trips, and the sum of WI. So the coordinates, again, we sort this using an increasing order. So this is 10, 15, 20, 25, and 30. And this corresponds to center D, A, B, E, C, and F. And we assign the values for WI. So this is 300, 200, 400, 400, 500, and 600. And we look at the cumulative values for WI. So this is 300, 500, 900, 1300, 1800, and 2400. And we already compute the half of the weight of the sum of the weight, which is 1200. So we can use that data point to find the coordinate for y. So this is not greater than 1200. This is not greater than 1200. Not greater than 1200. This is greater than 1200. So our coordinate in terms of y is 20. Then our optimal location for this new facility is given in terms of x and y. So x star, y star is equal to 30 and 20. And you're done. Any questions?
Is the value of the, for example, 1200 strictly greater than, or can it be?
That's a good question. So the question is if the value for half of the sum of the weights needs to be greater, or it could be greater or equal. The answer is it could be greater or equal. Okay, so if it's 1200, then that's it. Any other questions? No. So you can use this solution for revising your homework. Make sure that you have the right answer, and keep your homework so you can study for the exam. Any other questions? Okay, so the video for this lecture is going to be available today. So I'm going to post this video in case you want to refer back to this.